Right, David. Let's now take a step further. You've introduced us to global heating, if you like, and how it works and how it happens, and the balance and imbalance between energy in and energy out. Can you take it a step further and say, well, so what? What's the effects of the imbalances and all of that?
Delighted. One of the ways we measure the imbalance is in terms of what we call the change in concentration of the greenhouse gases.
Yeah.
And what's happened since the beginning of the Industrial Revolution is we've added about 100 parts per million, which is how we measure greenhouse gas concentration by volume of the amount of carbon dioxide in the atmosphere.
Yeah.
That feels like a small amount. It's only a trace. Remember, about 80, 90, 95 more percent of the atmosphere is completely transparent to the infrared energy as well as to light energy. So that doesn't count. It's only these trace gases, which are the greenhouse gases, that control the temperature balance. So when skeptics tell you, greenhouse gases represent 0.04% of the atmosphere, therefore we can ignore them, you say, actually they make up 100% of the control mechanism on climate.
Right.
Ignore them at your peril.
Right.
So parts per million is how we measure it. The problem is that if we increase carbon dioxide in the atmosphere and it starts to heat the planet up, to try and bridge the gap, if you like, between energy in and energy out. So the hotter the planet gets, the more energy it radiates. And it tries to re-establish equilibrium. But it also sets off a whole family of what we call feedback processes as it does so. I could name many of them. People often say to me, David, what on earth is a feedback? Well, if we were in a room with a public address system and we got a technician turning the knob on the amplifier and I was speaking and he starts to turn the amplifier up, it would eventually start going with an echo to what I was doing. And he turned it up a bit more and it would start to feedback and we'd go into scream and overload and everybody in the room would be putting their fingers in their ears and just turn that thing off.
Yeah.
Because the signal from the loudspeakers is being picked up by the microphone, amplified by the amplifier, and pushed out again by the speakers, picked up by the microphone, back through the amplifier, out through the speakers, picked up, and is going to scream level.
So
that's feedback.
Increasing
in volume as it goes. Absolutely.
So there's an amplification.
It goes into self-amplification. Another way of looking at feedback is one of my favourite stories. I think almost everybody who sees this and listens to this has tried to run up the down escalator at some time in their life. I came across two people who hadn't, and both of those had been subject to very strict parental control and were highly jealous of their brothers and sisters who had a go. The down escalator, you're at the top of it, that's safe space. You can allow yourself to go down the escalator because you're strong, you can run well, knees are in good shape. And yes, John, your knees aren't, which is why I stick my tongue out at you. Quite private joke. And you're confident you can run back up to the top, no problem. If you let yourself go down a bit further, you can still run back up to the top, provided you've got good stamina.
Right.
But this escalator is sharp. It's got sensors in it, and it knows how far down you've gone.
Right.
And the further you go, the faster the escalator works.
Right.
So at the top it's fine. You go down another 10 steps and it starts to go faster and you have to run a lot faster to get back up. If you go down even further, you may find that you're just running flat out and it's still slowly taking you down and getting faster and faster. And that's a tipping point, a turning point in the feedback process of the escalator. And this escalator is even sharper. It's also got time constraints built in. You do that today, you may be going down to step 15 before you run out of steam.
Right.
Tomorrow it might be step 12.
Right.
And a week later, step 10. So the longer you leave response to the feedback system, the harder it is to stop it. So let's think of that. That feedback amplifies the signal. It takes, if you like, the signal from carbon dioxide and makes the effect much more than it would have been if it was just carbon dioxide on its own.
That's why you can only go down to step 10, because it's accelerating.
That's correct.
Down a lot.
So, for instance, we release carbon dioxide, the temperature starts to go up.
Yeah.
Warmer air absorbs much more water vapour.
Mm.
Water vapour is a greenhouse gas.
Mm.
That increases the heating. The temperature gets higher.
Mm.
That increases the amount of water vapour. That increases other things. And the feedbacks increase the rate of heating. That melts ice. Ice reflects a lot of light back out into space without it becoming heat.
Yeah.
With less reflection, the Earth absorbs more heat.
Yes.
Warming increases, ice melts faster. That increases the rate of heating, that increases the rate of... You've got the idea. So there are many, many of these mechanisms which are feedback amplifiers of climate change.
And also the oceans and also the forests. So if the forests die, some areas presumably, you won't have there, you have another acceleration, because that dampener, if you like,
That's right.
is out.
That's right.
And the same if the oceans can't absorb so much, then
That's right.
their capacity is...
Hotter water, for instance, absorbs less carbon dioxide. So
Yes.
the way that the global commons absorb what we put out from
Yes.
our fossil energy use becomes less efficient.
And
And that increases the amount that stays in the atmosphere. That's another feedback mechanism.
forests aren't there to do the absorbing.
Precisely.
That's really helpful.